So welcome back everybody, and this second lecture is dedicated to the what is called data mining in healthcare. So in the previous lecture, we will assess the importance of the big data in the healthcare. We will see how there is several benefits from the customers, from the consumer, in particular the patient, but also how improving the data collection, but also the way how we can share the data and analyze the data will affect the entire healthcare systems. Now, in this lecture, we start to go in deep to understand what we mean for, first of all, data mining, and also which is the most important technique to assess, to analyze, and especially to classify and divide this huge amount of data, especially in the healthcare system. So first of all, we have just the first slide is a brief introduction to the evolution of data science. Then we start to understand what we mean for data mining in healthcare. And we will assess the three most important data mining techniques, such as the classification, regression, and clustering. Then we understand particularly the difference between partitional clustering and hierarchical clustering. And at the end, we introduce the density-based clustering. So let's start with the first topic. This lecture is divided in two topics. The first focus on data mining in healthcare. Then we will see specifically which technique is used into the healthcare system to analyze, to assess, to create different group of data, clustering and classification. So this is just a brief evolution. So start before then the 1960 there was just an empirical science, and so there was any sort of theoretical science. Then we have from 60 until 1950 years there was basically that each discipline had to grow theoretically, and there was also the start to develop a different model and they motivate the experiment, generalize and understanding how different experiment can be generalized to the entire population, for example. But what completely start to change the way how we can compute or how we can develop the research, especially when we have a big number of observation, is starting from the computational science. So over the last 15 years, most disciplines have grown a third, and a computational branch, for example, the empirical, theoretical, and computational ecology, physics, linguistics, has completely changed the approach of the science, especially in the way how they start to collect the data and analyze the data. And computational science traditionally means simulation. Simulation, it means to forecasting, for example, if we are in healthcare or in pharmacy or in medicine, for example, forecasting how will be the impact of a new vaccine, how will be the impact of new disease. So they start using a mathematical and statistical approach to doing some simulation, so forecasting and predict some specific events. What is completely changed the way how the science to face, especially in terms of data science, started roughly around the 1990. So there was an increasing flow of new scientist instrument and simulation, especially from the computers, from the digital devices, the ability to the economically store and manage petabytes of data online that was absolutely not available 3, 4, 5 days ago. So the ability to collect the data, but also the fact that everyone can have access to this data. Then also the internet, a computing grid that takes and all the activity that universally accessible, and also the way how we can manage the acquisition, the organization, the visualization represent one of the most important transition into the digital technology and to the data science. So in the last 3 decades, there was a completely transition toward the digitalization of the data science. And this is just a brief introduction. Of course, we will not talking about during this lecture all the evolution of the data science, but it's very important to understand how and when start this new way to assess the data, to collect the data, but also the fact that this data is quite cheap compared. You can imagine how it was hard 15 years ago to collect the data about one specific disease, because all the data was not collected, was not digitalized, was just maybe registered on the paper. Now you can have access to trillion of different database of the patient, of the vaccination, of any sort of appliance into the medicine, drugs, and so on. And data mining is represent one of the major new challenges. So let's start to have a look at what is data mining, what we mean for data mining in healthcare. So data mining involves uncovering patterns from very vast data store and using that information to build a predictive model. So the aim is to create a data set to predict some model. And also the data mining in healthcare today is the most part an academic exercise with a few pragmatic success in needs-zero story. So anyway, the academics, of course, all when we're talking about academics, we are talking about all the researcher, all the academic people that working and analyze the data, and the scientists as well. So let's have a look at the first two definitions and the purpose. So as a definition, we can define the data mining as analyzing large data set to discover the pattern and use of those patterns to forecast and predict the likelihood of future events. So the aims of mining data is to collect and also to aggregate or disaggregate or create a category or subcategory. But anyway, the aims is to predict some future events. And the purpose that inside the healthcare sector allow the health system to analyze their health system data to improve care and reduce costs by better tailoring and anticipating the right care to the right patient at the right time. So this is just the first way how we can start to enter into this concept of data mining in healthcare. Data mining, of course, have also to do and is correlated to the knowledge discovery from the data. So the extraction of interesting, not trivial, implicit, previous unknown potential use for patterns, or knowledge from huge amount of data. So the data mining basically aims to increase, first of all, the knowledge through the data that we have. That we can collect, or maybe that is just collected, but aims of the data mining is to extrapolate, to create different categories, different subcategories or group, but the aims is to forecast and to analyze and to predict future events, especially in the healthcare. When we're talking about future event, we're talking about predicting another pandemic, predicting the impact, for example, of new drugs impact on cardiology, because we have now so much amount of data that we can forecast. Before, it was not very easy to forecast any sort of impact, especially 3-4 days ago, or maybe 5 decades ago. when we didn't have access to this huge amount of data. There is also an alternative name of the data mining, that is a knowledge discovery mining in database, that is also called the KDD, that is also knowledge extraction, data pattern analysis, data archaeology, data dredging, information harvesting, business intelligence. So there are different ways. Now we call anyway data mining because it's very important that you understand the meaning. Then there is a different way how we can name this technique to aggregate, to use, and to treat and analyze this data. So now let's have a look at the multidimensional view of the data mining. So which is the data to be mining, to data to be dredging, if we would like to use a similar terminology. So the database, the dataset, that is an extended relational, object-oriented and heterogeneous and legacy data warehouse, transaction data, stream, spatio-temporal, time series, sequence, text and web. So there are different set of data that we can analyze, that we can treat. For example, the time series. The time series, if you are quite familiar with the statistical or with economic or econometrics, is represented by several observations, maybe 20 here, for example, observation of all the impact, for example, of the tuberculosis into some specific group of the at a demographic level. So imagine that you have 20 year observation, one in one specific country. So every year you have the number of cases, the percentage of cases, you have all the data correlated to the age, to the sex of the patient, and so on. So if you imagine that you have 20 years observation, we are inside the time series, but there is also the spatio-temporal. There are also different data correlated to the geographic position. So we can mine any sort of data, and when we're talking about aggregating this data or try to focus or separate some specific group, because maybe the aims of our research is to conduct, for example, a regression, because we would like to see. So we have 20 years of observation of tuberculosis around the world. We can, using the regression, using this, for example, econometric or statistical analysis, to forecast what's going on or how will be the future impact of tuberculosis in the next 5 years. And the knowledge to be mined from the data mining is, first of all, the characterization of the data set, the discrimination in terms of maybe we want to discriminate some data that are not useful for our research, the association with different, for example, disease, to see why different disease maybe have some common variables. The classification, how we can classify different disease, how we can classify the different patient correlated to the use of different medicine or different drugs, the clustering, so the dividing in different groups, the trends and deviation, and the other analysis. Then there is also the descriptive versus predictive data mining. So we will see later this difference. And there is also the multiple integrating function and mining at multiple levels. So the most important technique that are utilized in data mining are the data intensive, the data warehouse, it's also called the OLEP, machine learning that we will treat. We will focus specifically machine learning because machine learning is one of the most used technique into the healthcare. pattern recognition, visualization, high performance, and so on. We will focus on the next two lectures on machine learning. And the application is that can be adapted to the data mining will start from the healthcare to retail, telecommunication, banking, fraud analysis, biodata mining, stock market analysis, because we can categorize, we can subdivide any sort of big data that we have, if the purposes are, for example, to mining or to extract the data from a time series or from the spatio-temporal observation and so on. This is just an overview, especially when we're talking about the data mining. So, continues on the data mining. So, what kind of data? So, which kind of data we are looking for, and which is the aims of the data mining in terms of the objective of the data analysis. So we have the database-oriented data sets and application. So relational database, data warehouse, transactional database. And then we have advanced data set and advanced application. So data stream and sensor data, time series data, temporal data and sequence data, such as, for example, the biosequencing in the biology science, structured data, graph, social network, multi-linked data, objective-related data, heterogeneous databases and legacy database, spatial data, and so on. So this is any sort of data that we can treat generally fall into what is called data mining. But anyway, data mining should be divided and should be not confused with what is called the data warehouse, where the data warehouse is an historical database designed for decision support. Meanwhile, data mining can be applied to the data in a warehouse to help with a certain type of decision. For example, if in terms of decision, if we have warehouse data but are aggregated or are not well specified, we can subdivide in different categories, and we can run using different algorithms to see if different groups, for example, in terms of a patient, if they have some variables in common. This will help to understand, for example, if one specific drugs or medicine can affect a different group of patients. So that's the reason why it's important to understand the difference between warehousing data and mining. Mining has to do much more on treating the data, so not just storing the data and interpret the data, but as much more on performing and analyzing the data. And the proper construction of data warehouse is fundamental to the successful data mining, of course, because if the warehouse data are not accurate, any sort of different algorithm and techniques that will apply to data mining will be not correct. And also the knowledge, what is called, just to have some notion about, because maybe you will read a lot of times the knowledge discovery in database. So the data mining basically is actually one step in a larger process as known as knowledge discovery in database. So the knowledge discovery in database model compromise the data selection, data cleansing, enrichment, data transformation and coding, data mining, reporting, and displaying, discovering knowledge. So it's much wider. Maybe one you can hear, just to remember that when we're talking about the knowledge discovery in database, I have nothing to do with the data mining. Data mining is one part of this holistic knowledge discovery of the database, but we will focus on data mining. So let's have a look at the process of data mining. First of all, we have the acquisition and selection. So during this stage, the target set is created with original data. So we had to acquire, for example, the data correlated to the whole cardiology in the hospital. So we had to select all the data correlated to the cardiology, correlated, for example, and divided by private and public hospital, divided by also by the different treatment to cardiology, the different level of risk in cardiology, and so on. Then we have the pre-processing. So data is formatted, of course should be formatted and should be standardized, because we have to use this data, and its quality is standardized because we had to use the same standard data that come from different sources. That could be different healthcare institution, could be from the local government, could be from any sort of sources. But it's very important that during the pre-processing that his data is formatted and started, and also the data is standard. Then we start with the mining. So it's actually a step of detecting pattern and knowledge. Then we have the interpretation when we have the insight from the pattern mine. So once we run our algorithm and once we perform our analysis, we can interpret the data. So this is the typical process in mining data. And mining data represent basically the most important aspect in terms of performing any sort of analysis, because using the mining data we can first of all decide which category of information use, how we can divide the information, how we can select the data, and also which different technique we can use to assess which is, for example, if the aims of our study is to assess which variables affect, for example, one patient in cardiology. So we can include several variables such as the level of the blood, such as the pressure, such as for example, the diets. So we can create a different list of variables to see how these different variables affect one specific patient.